Hi, welcome to my channel, High School Physics. This channel is designed basically for high school students who really struggle in understanding physics. So today's topic I'm going to talk about is capacitors. So let's start with today's topic, capacitors. Now, what are capacitors? Capacitors are electronic components that are used to store charge. The main purpose of capacitor is to store charge. So the capacitor basically consists of two metal plates. It's connected to the DC supply. So when voltage is applied, current starts flowing. One of the plates will start collecting positive charges. The other plate will accommodate negative charges. So because we have positive and negative charges, we can label this as plus Q and the other plate as minus Q. Now, once the capacitor has stored the charges, what happens is there exists an electric field between the plates. This is an electric field. So it's very obvious the capacitor depends on the voltage to store the charge, and hence we can write C is equal to Q over V, where Q stands for the charge and V stands for the voltage. So the farads is the unit of capacitor. Farad or farads is the unit of capacitor, which is more commonly used. The other unit of capacitor can be coulomb per volt, because the unit of charge is coulomb, unit of volt is V. So it is coulomb per volt. So from this, what we can understand is bigger the plate, greater is the storage of charge. So when more charges are stored, that means the capacitance increases. So therefore, we can write C is directly proportional to area of the plates. So if I were to draw the capacitor, so this is the area of the plates. So bigger the area, more is the capacity of the charge, and hence the capacitance increases. And there exists distance between the two plates. So lesser the distance, greater will be the capacitance. So that means C is inversely proportional to D. So if I combine these two expressions, we can write C is proportional to A over D. Now this can be turned into an equation by using proportionality constant. In this case, it will be epsilon naught, epsilon R, A over D. Now what is epsilon naught? Epsilon naught is absolute permittivity in free space. So its value is 8.854 times 10 power negative 12 farads per meter. Now, what is epsilon R? Epsilon R is relative permittivity. So relative permittivity depends on what is called as dielectric. So if we go back to our previous slide, here we have a dielectric. So what are dielectric? So this is, I want to label this. This is nothing but dielectric. Now what are dielectric? Dielectric are nothing but they are insulators. Dielectric is an insulator between the metal plates. So this is an insulator, we can say example as Teflon, paper, glass, paraffin wax, etc. So you can see that Teflon is different material compared to paper, and paper is different to glass. So therefore, depending on what sort of insulator that is present between the plates, the value of relative permittivity varies. So relative permittivity value depends on dielectric. So this is a very important expression for capacitor. Symbolically, the capacitor is represented as two parallel lines, where one line, this is parallel because you have got two metal plates. So you should make sure that the lines are of same length. So in the next video, I'll be talking about series and parallel capacitors, and I will also do the derivation. So don't miss that video. Thank you for watching. If you like my video, don't forget to press the like button, share the video with your friends, and click the subscribe button so that whenever I post new videos, you will be notified, and also press the bell icon. Thank you for watching. Take care. Bye.